Hi students. So as per our discussion regarding the thin film type SPRTs, these are more rugged than the wear type IPRTs. Okay, thin film type IPRT. Sorry. So these are more rugged than wear type IPRTs. Okay, and it is of low cost compared to wear type IPRTs. They are produced by sputtering. Okay, so that is the difference between the the wear type IPRT and the thick film type IPRT and thin film type IPRT. In case of thick film type IPRT, only you see this is basically done by screen printing. See, this is done by screen printing. Okay, that means the film is produced by screen printing method. Here it is produced by sputtering method. That is the difference. Okay, and once again, what are the materials? Platinum is used for thin film, only 1 micrometer. Okay, so the film thickness is only 1 micrometer. There, in the thick film case, it is 5 to 10 micrometer. Compared to this, it is very thin. Okay, only 1 micrometer. Nickel, alpha value nickel is also used for thin film. Alpha value is very high. Its rho value, that means the resistivity value, alpha value is high, but the rho value is lower than the platinum. So if I can compare nickel with platinum, then rho value is lower. Okay, and nickel has higher non-linearity than that of platinum, and it cannot be drawn into a wear of fine diameter. These are the negative points of nickel. Okay, easily contaminated and oxidized compared to platinum. So these are the all drawbacks of nickel. Still, for making thin films, it can be used. Okay, and another one is iridium. Iridium resistance thermometer (RTD) is preferred, though it is costlier than the others. Okay, so iridium, its property, thermal expansion coefficient, is approximately equal to alumina, and its alpha 1 is basically compatible with the alpha of copper. Okay, and it is mostly used for surface temperature sensing. Okay, so these are the attractive features of thin film type IPRTs. Okay, another one is C, RHFE or PTCO. Okay, so these are the two variations of, this is basically formerly used resistance thermometer. Okay, so for RHFE type resistance thermometer, okay, so what is the process of making RHFE resistance thermometer? Deposit iron in RH powder. So you have to take RH powder first, then you have to deposit iron into the RH powder. The powder is dried, then the powder should be dried, sintered, and then hot drawn. Okay, so in this way I am making an alloy of RH and Fe. Finally, it is annealed for straying in an atmosphere of hydrogen at about 1100 degrees centigrade. The sensor is designed in the double capillary form. Okay, and the sensitivity range is 0.5 to 30 K. And this is the governing equation. Temperature is J equal to 1 to N alpha J into lambda 1 R plus lambda 2. So alpha 1 and alpha 2 are chosen to keep this value in between the range -1 to +1. N is chosen for curve fitting with a specified deviation. Okay, so N value is chosen, and this should be in between -1 to +1, and alpha J is, it is the thermal temperature coefficient. Okay. So in this way, in a similar fashion, platinum cobalt IPRT also can be made. So these are the different categories of SPRTs and IPRTs. That means RTDs. Okay, so these are the all classifications of RTDs. So finally, what is my conclusion? Stem type of RTD, that is the basically SPRT, and wear type of RTD, these are basically the IPRTs. Which type? Wear type IPRTs. Okay, so these are the discussion. This is the discussion about RTD. Okay, so if you have any questions or any query, you can contact with me. I will try to solve your problem. Thank you very much.